So this is question from 2019 May June paper 2-1. So what they are saying here, figure 9.1 shows a parachutist falling vertically towards the ground. The mass of the parachutist is 60 kilogram and his weight is 600 Newton. State what is meant by mass. Mass is the quantity of matter present in a body or amount of matter present in a body. And the next question is, what is meant by weight? So the weight is gravitational force acting on us, which is downward. Whatever the gravitational force acting on me is my weight. Whatever the gravitational force is acting on you is your weight. So gravitational force acting on an object is called its weight. In a gravitational field. Now they're asking you to calculate the acceleration of parachutist when the air resistance is 200. So it is shown in the question. Downward is the weight and upward is air resistance. So we have two forces. So here we have to find out the resultant of the two forces in order to calculate the acceleration, say that how much acceleration object possess due to the resultant force. So for resultant force, when the forces are opposite in direction, we subtract the forces to find resultant, and the smaller force will be subtracted from the greater one. So 600 minus 200, 600 minus 200, and it is 400 newtons. Then acceleration is force per unit mass, basic formula from Newton's second law. 400 and mass, it was given in the question, and it is 60 kilogram. So 400 over 60, it is equal to 400 over 60, 6.6667. 6.67. So in two significant figures, it will be 6.7 meter per second square. Don't forget to write the unit. Okay, now they are saying the parachutist falls from the rest at time zero. He accelerates non-uniformly until he reaches a terminal velocity of 44 meter per second at 30 seconds. At 40 seconds, the parachute opens. He decelerates for 4 seconds, reaching a smaller terminal velocity of 5.0 meter per second. He then falls at this speed until he lands on the ground at 200 seconds. Okay, what to do with this? Draw the speed time graph for the parachutist. So they have marked all the things, all the speeds and time. You are required to draw the graph only. So first we have to break it, and at time zero, the parachutist was at rest. It means at time zero, his speed was zero. Okay, then he accelerates non-uniformly until he reaches a terminal velocity of 44 at 30. We know terminal velocity is the point when weight is balanced by air resistance. And at that point, object continues with a constant speed. Before that, the pattern is like acceleration decreases. It's a speed time graph, so that usually when you study the topic, you will get to know that the graph is like this. So if the graph is like this, so this point is the point when the object reaches the terminal velocity. So here, at what time? At 30 seconds and 44. So we have to find out 44 here first. So it's Five boxes are making 10. From 40 to 50, there are five boxes. It means one box is representing two. So for 44, we have this marked. This is 44, and at how much time? It was 30 seconds. So 30, 40 for 10 boxes. One box is 4, 4, 8, 12, 16, 24, 28, and 32. So here in between, somewhere here, it is like this. So till this point, the graph is like this. And then at 30 second, from 30 to 40 second, he continues with his acceleration for 4 seconds. So 4 seconds from this point, 30, 34. 30 to 4 seconds is 34. This is 28, 32, 36. In between here, it will remain at this speed. Then for 4 seconds, reaching a smaller terminal velocity. Acha. No. I'm sorry. It was written at 30 second. At 40 second, he opens the parachute. Oh, sorry. So at 40, till this point, so it will be like this. And now he will open the parachute. The parachute will cause a deceleration, sudden decrease in speed for 4 seconds. Then it reaches a smaller terminal speed of 5. So where is 5 here? 5 is in between there is 5 and after 4 seconds. So from 40 to 4 is 44 at this point. So it will be like this. He then falls at this speed until he lands on the ground at 200 seconds. So till 200, it will move with this. It will continue with this. So this is the graph, complete graph. Calculate the average deceleration of the parachutist between 40 to 44 seconds. So average deceleration is total change in velocity per unit total time. Let's change the color. What happened? Color is not changing. Hmm. Acceleration is change in velocity over time interval or total change divided by total time in which the change is taking place. So from 40 to 44, at 40, the speed was 44, and at time 44, the speed was 5. So initial speed is 44, final speed is 5, and time 4 seconds. So it will be 5 minus 44 over 4. 5 minus 44 over 4, 9.75. 9.75 will be 9.8 in two significant figures. It is negative. Deceleration, it's obvious it will be negative, so we will write minus 9.8, it's only 9.8 meter per second square. I'm not writing the negative sign here because it is obvious that deceleration is negative. Explain in terms of the forces involved why the parachutist reaches a terminal velocity at 30 seconds. So why that parachutist reaches the terminal velocity? Because air resistance becomes equal to the weight of the object and resultant force becomes zero. So he moves with a constant velocity. So for 1 mark, I will write air resistance becomes equal to the weight. The parachutist decelerates when parachute opens. They're asking why. Okay, the parachutist was moving with the uniform speed, terminal velocity. Now, when he opens the parachute, he suddenly gets a drop in the velocity. He decelerates. So why is he decelerating? When we open the parachute, the surface area of the parachute creates a greater air resistance on the parachutist. Due to the greater air resistance, the resultant force becomes negative if we compare it with the weight, because initially it was zero, air resistance was equal to the weight. But now upward force air resistance is more than the weight, then it will cause the object to decelerate. So what are we going to write here? We will write the air resistance increases 2 marks. So air resistance increases, which as a result resultant force acts upward. Okay, obviously object is the person is moving downward, but the resultant force is upward. So it is opposite to the motion, so it will create a deceleration. The second terminal velocity when the parachute is open is smaller than the first one. Why? Because uh, when air resistance increases, it reduces the velocity. That when speed reduces at less speed, less air resistance is required. So that's why the decrease in velocity. First, the parachute opens. When the parachute opens, the air resistance acts in upward direction more, causing the person to decelerate. This deceleration, when decreases the speed, the air resistance also decreases because air resistance depends on speed. The more the speed, the more air resistance is there. The less speed, the less air resistance will be there. So they are asking the second terminal velocity when the parachute is open is smaller than the first one. So what we are going to write that air resistance decreases due to a decrease in weight, and it again becomes equal to the weight. Air resistance decreases due to the decrease in speed, then it again becomes equal to the weight, but now because the speed has decreased, so it will be less speed than the before. Okay, so 2019 is for that paper. We have another question, question number one of 2019 May June paper 2 variant 1. So figure 1.1 shows the distance time graph for a journey made by a cyclist between town A and town B. Okay. The cyclist leaves the town A at time 0 and arrives at town B at time 4 hours. Determine the distance between the two towns. So we can see here that at 0 the cyclist leaves town A, and at 4 the cyclist arrives at town B. So they are asking you to find the distance between the two towns. It's obvious that from zero till this point, it's a distance time graph. So we can easily find out that it is 58. So distance is 58 kilometers. Don't forget to write the unit. Determine the time for which the cyclist rests during the journey before he reaches town B. So they are asking you to calculate the time during the journey when the cyclist was at rest. How do we find it? Because it's a distance time graph. So the gradient of the graph gives us speed. So if we want zero speed, it means we have to find a point in between where the gradient is zero. So here I can see from this point till this point, the gradient is zero. So what is this point? This is, I think, it is 2.2 and this is 3.30. So almost 0.8, 0.8 hours, I believe. You can, yeah, 0.80 hour. Now, the speed of the cyclist near the end of the journey is greater than the speed at the beginning. State how the graph shows this. It's a distance time graph. So for distance time graph, the gradient gives us speed. If the gradient is more, it means the speed is more. If the gradient is less, it means the speed is less. So how are we going to see this near the end of the journey and near the beginning? You can see here that this is the beginning of the journey. This is the end of the journey. If we compare both, you can see here that this angle is smaller than this angle. If there is more angle, it means the gradient is more. So if there is more gradient, it means the speed is more. So we can write that at the end of the journey, the graph is more steeper than at the starting of the journey, which shows that at the end of the journey, the speed is more. Because they are asking you how the graph is showing this. Graph is more steeper at the end of the journey. Calculate the average speed of the cyclist from town A to town B. Average speed is total distance divided by total time. Total distance over total time. The total distance we saw, it is 58 kilometers, and the total time, do remember here what normally students make mistake. They consider total time as 5, which is wrong because the cyclist reaches the town at this point at 4 hour. After that, it is at zero speed. It is at rest. So 4 is the total time to reach the town B. So 58 divided by 4, 58 divided by 4, it is 14.5. So I can write 15 meter, not meter per second. Distance was in kilometers and a kilometer per hour. I hope it is clear to you. Okay, now we have a question from May-June 2022. From 2019, now we are here at 2022. Don't worry. I think 2020 and 21 is missing. So I will add them in the end. Whatever right now we have, we are going with the flow. And at the end, I will include it. Okay, here figure 1.1 shows a water skier pulled horizontally across the water surface. The mass of water skier is 60 kilogram. The gravitational field strength is 10. After 2023, it was 9.8. It is 9.8 basically. But before that, it was 10. So in past papers, you will get 10 before 23, and it is fine. And but in exam, you have to use 9.8 until and unless it is not mentioned in the question to use a particular value, you are going to use 9.8 for G. It is written on the first page of the question as well, paper as well. So the mass is 60 kilogram. They're asking you to calculate the weight. Weight is mass times gravity. Mass is 60, gravity is 10. It is 600 Newton. Mass and weight have different units. State two other differences between mass and weight. One is the basic difference that uh, mass is a scalar quantity. Mass is scalar while weight is vector, the first one. And the second one, units, we know mass is kilogram, weight is Newton, but they are not asking for the unit because they have mentioned different units and you are required to tell some other difference. Mass remains same everywhere, but weight varies according to the gravitational field strength. So I will write mass remains same everywhere while weight depends on gravitational field strength. A boat pulls the water skier to the right with a horizontal force of 50 Newton. The water skier travels at a constant speed. Explain in terms of horizontal forces acting why the speed is constant. Speed is constant means acceleration is zero. Acceleration is zero means resultant force is zero. And resultant force is zero when forces are balanced. So it means forward force is balanced by the backward resistance force, like uh, 50 Newton is balanced by other 50 which is acting in opposite direction. So for 2 marks we will write frictional force is balancing the force to the right. Resultant force is zero. The horizontal force acting to the right increases from 50 to 70 Newton. The sizes of any other forces are unchanged. Calculate the acceleration of the water sphere. Okay, at 50, both the forces were equal and the resultant force was zero. But what is happening here at now it is not 50, it is 70. So it makes it the resultant force 70 minus 50, which is 20. So for acceleration, it is force per unit mass. Force is 20, mass it was given in the starting 60. So 20 over 60, 0.33. So 0.33 meter per second square. Don't forget to write the unit. Okay, now next question is from 2023 May-June paper 2-1. So previous question was 22 again. Okay. Aircraft pulls a glider along a runway as shown in figure 1.1. Figure 1.2 shows the speed of the glider during the first 12 seconds of the motion. Describe the motion of the glider in the first 12 seconds. It is 2 mark question. The first 12 seconds we can see here that in the starting the speed is increasing at constant rate, but at after this 6 seconds the speed is uniform. So from 0 to 6 seconds, speed is increasing at uniform rate, while 6 seconds to 12 seconds it is constant. In the first 6 seconds of the motion, there is a resultant force of 1800 on the glider. Use the increase in speed in the first 6 seconds, calculate the mass of the glider. So we know in first 6 seconds the speed is increased to, we have to find out first. It is 21, 22. Initial was 0 and the time is 6. First we will find out the acceleration. 22 minus 0 over 6, and then we are required to calculate mass. Mass is equals to force unit acceleration. So acceleration is 22 over 6, 33.67. Force is 1800. Remember, we have resultant force here, 3.67. So 1800 divided by 3.67, 490.46. 490.46, which makes is 490.5. So 490 kilogram. Determine the distance traveled by the glider in the first 6 seconds. I've already mentioned that a speed time graph area gives us the distance. So it's a triangle here. So we have to find the area of triangle. And for this triangle, it is 22 and the base is 6. So 1 over 2, 6 into 22. So 3 into 22. 66. 66 meter is the answer here. The glider has no engine and stays in the air with the use of convection currents. This is the part of thermal physics, actually. State what is meant by convection current. So, convection current, you have already, if you are seeing the past papers and if you have not studied this topic, so when you will study this topic, you will understand it that convection is basically the rise of hot air due to the less density, and the colder air falls back due to the higher density. Rise of hot air due to less density and cold air goes down due to higher density. So this is basically convection current.